Hello, everyone, and thank you once more for attending to these Higg FEM 2024 updates. And today we will cover the section 4, water use. And by now, I think all of you or some of you will know me. My name is Sandra Teixeira. I have a background in chemical engineering and I have experience in the textile industry, more than 24 years now. And 11 of those years were spent in the wet processing industry.
Sandra?
Yes.
Sandra, excuse me, but I was looking at the attendees. It seems that they are all still in the waiting room. Can anyone hear us now? Any one of the participants? Could you send a chat if you hear us?
Sorry, I need to start webinar.
Mm-hmm.
Started now. Okay, now I will restart again. Okay. So, yeah, they are increasing. Let's wait 1 minute so they can jump to the room.
Yeah, let's wait 1 minute so they can.
Yeah, I see the number increasing now on the screen.
I think you can start now.
Thank you so much. Hello, everyone, and welcome here. And we are very pleased to have you here today again. So, just an adjustment. So today we will cover the section 4, the water use for the Higg FEM 2024 updates. And by now, I think some of you already know me. My name is Sandra Teixeira, and I have a background in chemical engineering and 24 years of experience in the textile sector, and 11 of those years were spent in the wet processes. In the last few years, I've been involved in the environmental auditing and making water assessments, energy assessments, chemical risk assessments in several countries in Europe, as well in Latin America. We also would like to make you a note regarding this web in Zoom, that during the webinar, the audience will be muted in order to ensure the best audio quality. But in any case, feel free to reach out to us with your questions throughout the Q&A function. And at the end, we will have a space in order to discuss and clarify your questions that may be raised during this presentation. And also, we will provide you with the PDF of this presentation, as well the video recording at the end. Also, we would like to make the note that these materials are copyrighted by Cascale and ZD8 and Leadership and Sustainability, so please do not share them outside your organization. And for the agenda today, we have the welcome and LES introduction, as we have done, the introduction to FEM, or the overview of the schedule of this cadence, and also section 4, the water use, the definitions of water, some added value by implementing the Higg FEM, about leadership and sustainability, and the question and discussions at the end of the session. So looking again into the Higg FEM 2024 cadence overview, and as a reminder, the purchase of the modules can be done from November 2024 until October 2025, and the assessment can be done also from November 2024 until December 2025. The posting can be done since January 2025 until December 2025. and the verifications are done since January 2025 until December 2025. Please note that if you wish to have your self-assessment with content logs for benchmarking, you should do it before the 30th of April 2025. So looking into the changes of this cadence 2024, and here diving a bit more into the water use section, here we can see again the trail of the verification and which are the key areas of impact that Higg FEM framework covers. Today we will see water use. And moving into the levels overview. And as you may know, there is a finite amount of water in Earth that increased global demand for water not only creates the risk for our business, but also creates risk for our communities and planet on a broader scale. So the operational, environmental, and financial impacts of water use are key issues for facility operations. Driving efficient water use reductions throughout facility operation is an important of focus for all the factories. So, and having then the overview of level 1, here we can see the changes that we had this cadence in 2024. A new sub-question was added into question 3 of level 1. Then we have level 2 questions that remain the same as in the last cadence, and level 3 questions. So in highlighted in bold here, you can see which are the new additions in 2024, as well under the underlined questions were questions that were added in the previous cadence of 2023. Having the introduction of water and there is a finite amount of water on Earth, therefore driving efficient water use and reductions is at the facility is a must. The water section encourages you to identify all water sources that your facilities may use, which operations and process at your facility use the most water, meaning which are the most inefficient process that you may have inside your facility, to track and report the quantity of water consumption at your facility, to evaluate and adopt solutions in order to reduce this water use, and implementing leading practices to reduce water use at your facility. Also to contribute to sustainable water management and stewardship activities in your community. The water use then is divided as production and domestic purposes, and the definition for water used in production is water used in manufacturing process or operations, like dyeing or rinsing water, steam generation, cleaning of equipment, components or tools that contact with the product during the manufacturing process. And the water used for domestic purposes is all the water used for washrooms, sanitation, food preparation, landscape irrigations. Sorry, and these are the examples for production water use for, domestic purposes. Then we have the definitions of blue water. And if blue water is considered as fresh surface and groundwater, water coming from lakes, rivers, reservoirs. Surface water is water that is naturally occurring on the Earth's surface, like lakes, rivers, streams, wetlands, etc., and has low concentration of dissolved solids. Groundwater is water that is beneath the soil surface, and the voids are substantially filled with water. And we have also the municipal blue water, that is water provided by the municipality or other public provider with unknown origin, that can be blue or gray water. The municipal water with origin unknown, that is water provided by a municipality or other public provider with unknown origin, blue water or gray water. Also, under the category of blue water, we have the brackish surface water or sweet water. And brackish water is saltier than fresh water, but not as salty as sweet water, resulting from the mix of seawater with fresh water. And this is hostile to the growth of plants. Also, condensate from external steam sources, that water that is generated from the condensate of steam sources that are not located at the facility. And we have also the rainwater, that is water in the form of precipitation, like rain or snow, that is harvested within the facility and stored for use. Looking at the grey water sources, and grey water is defined as water that has been polluted by human activity, like the industrial or domestic sources. And here we also have municipal grey water, that is water provided by the municipality or other public provider that is generated by grey water. The recycled water, wastewater that has been treated using physical, chemical, or any additional treatment process to meet a quality which allows the water to be used again into the process. And the reuse water, that is wastewater discharged from one process that is used directly into another process without any treatment. And the treated wastewater from external sources, that is wastewater that has been discharged and treated by an external source using physical, chemical, additional treatment process to meet the requested quality and be used again into the processes. And the untreated wastewater from external sources, treated and internally, meaning that is wastewater that has been discharged by an external source other than the manufacturing facility and treated at your facility using any physical, chemical, or any additional treatment process in order to meet the quality to be used again into your process. So looking at the summary of the new questions that have been added into the Cadence 2023, the tracking water use and sources, and this includes the rejected water from pre-treatment, the water treatment and disposal, including rejected water measurements, and monitoring and reducing water consumption by differentiating the domestic and production water use, and the adherence to groundwater restrictions and lead monitoring. Also related to water efficiency and conservation plans, like the increase of the grey water use, the reduction of the absolute water use, and the elimination to eliminate or reduce groundwater use. Implementing leading technology to significantly reduce water use in the manufacturing processes. Also, regarding external reporting and innovative practices, report water risk and consumptions to external standards, demonstrate a positive impacts on water catchment or basin area, and implementing leading technology practices. And of course, setting science-based targets on your water. So, looking into level 1 questions and what we have prepared according to for today for the tracking and water use. And this is, does your facility track water use from each water source your facility utilizes? And here, as we saw in the overview of the level 1 questions, we see that in this Cadence 2024, a new sub-question was added. Is your facility able to separate and report water consumption by facility type for tracked water sources directed from captured data without relying on estimation. Again, the idea of this question is really to differentiate from the facilities that are able to really measure their water consumption per each one of their sections or productive areas from those that are declaring their water consumption based on estimations or calculations. Another question regarding tracking water use. Question 4, does your water consumption you track and report include the rejected water quantity from pretreatment? And also here, often in the verifications, we found that facilities are not measuring this water quantity from pretreatment, meaning if you are if you need to prepare your production water with any kind of treatment, for instance, like a reverse osmosis or an ion exchange process, you need from time to time, or a part of this water will be rejected. And many times this water is not taken into account into the global volume of the water that you are consuming per each month or at the end of the year. So it's really important to keep your records updated and measure and include this rejected water that is an indirect source of water to your process. As a question, and if you say that you are tracking this water use, is please select the type of treatment that you are using. Does your facility measure water rejected from the pretreatment? What are the water sources sent throughout the pretreatment? And please indicate the annual quantity in meter cubics. Also, please pay attention in the units that you are using. Also is a source of mistakes, the units, or even sometimes when you are copying into or inputting your values into the Worldly platform, you need to pay attention into the list that you are showing for the units, because sometimes you tick mark one, but you tick mark the above unit measurement and not the correct one. So it's really important to cross-check all your information before submitting it into the platform. And what is another question related to the rejected is, what is the rejected percentage of water? And what is the method of disposal of this rejected water? As suggested uploads for this tracking water use, for question 4, we recommend the freshwater pretreatment process and flow and hydraulic diagrams, like the diagrams where we can really clearly see the distribution of your pipelines inside your facility. And going into the water section, level 2 question. So increasing gray water use. As your facility increased gray water use for any sources compared with your baseline, report the baseline quantity, report unit of measurement, and report the baseline here. So all these should be included. As the facility increased water consumption for each source compared to its baseline, and achievement for change in percentage in the water use for each source compared to its baseline. So meaning that a negative value will mean that you will have a reduction but compared to the baseline. And if you have a positive value, means that you increase your water consumption compared to the baseline. Also, you should describe the strategies used to achieve this improvement. And again, as suggested, uploads or documentation that will support you in your answers. Any documentation that supports an increase in grey water use was achieved, and the increase was related to specific actions taken by the factory to increase the use. For example, water consumption data and baselines, the evidence of the process modifications, if it is applicable, or any new equipment or work practices that are resulting in improvements. As level 3 questions, here you have reduction, the absolute blue water use. And the question is, can your facility demonstrate you have reduced your overall absolute water use, blue water use? And if you say yes, the question, a sub-question, how much has your facility reduced in terms of percentage? What is your baseline absolute quantity? To describe the strategies used to achieve this improvement, and the reductions in the water use due to reductions in production volume should not be considered as improvements, as these will not result in a substantial improvement. So, meaning that if you reduce your water, but also you reduce your production, of course, your water consumption will reduce because you are working less. However, this will not will be considered as an improvement in the water consumption reduction. Another question, or suggested uploads also for this question 2022 is 22, sorry. The documentation supporting a reduction in absolute water use was achieved, and it was related to specific actions taken by the facility. Also, as examples, water consumption and data baselines, the evidence of the process modifications or any new equipments or practices that resulted in these improvements in order to allow you to reduce these, the absolute consumption of blue water. Also, in the water section, there are quantitative data that is required. And the overall, one of those is the overall water consumption per year. The water source is used annually, so that's why it's so important to keep the recordings and the tracking all the water sources of your water. If you use water in production, track and document water consumption separately between domestic and production use. This is really important. Also, sometimes there is missing information here, or facilities are not yet able to track separately their water consumption, production from in the domestic use. And so it's recommended that you do that, or via measurements like flow meters or water meters. Documentation of water usage. And these are some of the questions that you can find in the FEM for level 3, level 2, and level 1 for the Cadence 2024. So looking a bit more about adding a value in the Higg FEM implementation. And again, we would like to show you LES team map where we are placed and where we have our experts based. In this table, you will be able to see again our Higg FEM local experts and the number, and also the trainers for the FEM, Higg FEM trainers. As referred, you can support or reach out to us also through LES Academy platform, that is a self-paced learning platform for your sustainability education. And we also would like to highlight our collaborative DHC services, as leadership and sustainability are chemical inventory verification services, in-check verification, and we are partnering with Clean Chain since November last year, and Clean Chain is an approved solution provider for the in-check generation. And having the benefits of generating ZDHC in-check reports with Clean Chain. So by using Clean Chain platform, the chemical inventory management, suppliers can upload and maintain their chemical inventories within Clean Chain, ensuring the up-to-date records. Also, the integration with ZDHC Gateway. So Clean Chain connects with ZDHC Gateway, allowing a seamless access to ZDHC chemical module and the extensive product library. Also, regarding the performance and monitoring, Clean Chain offers tools to track chemical usage, manage safety data sheets, and monitoring also overall chemical compliance throughout dashboards and scorecards. In addition, ZDHC, Leadership and Sustainability Current Services, we are ZDHC training approved. Also, we are in-check verifiers, and we are also supplier to 0, level 2, and 3 verifiers. So if you need any support in your verifications, kindly reach us, and we will be very happy to support you on that. Also here we have the local experts for the ZDHC services across the globe: Bangladesh, China, India, Pakistan, Portugal, Tunisia, Turkey, and Vietnam. And also note that the verifiers are authorized to perform verifications worldwide according to the customer requirements. Again, you can see our contacts here. With leadership and sustainability, our website, and our phone contacts, as well our global team.